Hi, we're here today to talk about our first holographic application we did, and this is for ShockTop. And the talk we're giving today is about how we designed this application to work in different spaces. So to introduce ourselves, I'm Jeremy.
And I'm Alex.
And we did some work with a small brewer based out of St. Louis. You might know them. But in all kiddingness, Anheuser-Busch is one of the largest brewers and distributors in the world, and they own a myriad of different brands. And when they approached us, they were interested in the future of TV advertising, how they can use holograms in order to tell their stories in a kind of new and interesting way, as opposed to traditional TV and print advertising. So the assignment they gave us was to look at one of their Super Bowl commercials they did as part of the last Super Bowl, and how to make that into an interesting and compelling holographic advertising campaign. So the ShockTop brand has had a long history of doing some pretty innovative types of advertising. They've projected their brand mascot on the side of buildings. They've projected it onto their print advertising, and obviously they've done a series of high-profile kind of video advertising campaigns. So the assignment they gave us was really to figure out how they can use the ShockTop brand mascot in bars, in stadiums, anywhere as a holograph. So the solution we came up with comprised of 4 pillars. The first of which was, really how we can lock this down and make it something which they can bring into these stadiums and public spaces. The second was, really how you can use the HoloLens in order to capture the voice of the people who are using the experience in order to drive the conversation. The next of which is, really how we represent ShockTop, because the brand mascot traditionally is shown, kind of either in a 2D or a 3D form, but they didn't really have a great representation of him, which can work, in a 3D holographic setting. And then the last problem we faced was, really how you place him and how you make sure that, no matter where they bring this experience, he can be put in a compelling and reasonable place. So the first of these 3 challenges are well known. We have a lot of experience doing Unity development. These are things which we know work, and we know are pretty easy. The last of which was challenging, and we're going to spend some time today talking about all of these with a bit of special talk about the last one, which is really about how we did this placement. So to give you, talk about the first pillar was kiosk lockdown. So this is something which is going to be put in a very public space, and it's imperative that the user cannot get out of the experience. The user can't use the bloom gesture to go back to the shell. The user can't change system settings. And to do this, we leveraged the kiosk lockdown functionality built right into the HoloLens. So this was super easy for us to do, and all we had to do was go to the device portal and simply enable this mode, and this allowed us to put the experience into spaces without worrying about the users getting out of the experience, even if they know the gestures, or if they're kind of flailing their arms around or saying "Hey Cortana" or any of these sort of interactions, which really are a problem if you don't have this in a kiosk lockdown.
Yeah, the second challenge there was the 3D modeling. So the first thing you have to remember when you design a holographic experience is that the HoloLens itself, the device, is a fully untethered computer, which means it has limited processing power and it has limited resources for you to use when you're showing things. So if you're looking at the model that we have, that they have used in their commercials, like we got that model from them, and it had around 400,000 polygons, and it wasn't reasonable for us to put that directly in the experience because of the performance limitations. So what we did, we took the model and we redesigned it from scratch to look the same but kind of simplified it. So it's important to optimize your models when you want to present them in a HoloLens application. Like in general, performance is crucial on HoloLens. Like you want to aim for 60 frames per second. That's crucial to get a fluid and nice experience with holograms that are like fixed and in their place and they don't jitter around.
And yeah, to give you some context about that, the model we got initially, was this model you see right here, and that was the 400,000 polygon. It didn't look great. It performed really poorly because of that polygon count. And this last model, which I'm showing right here, is actually 4,000 polygons, so a few orders of magnitude less, and looks fantastic. And this really shows how using proper textures, using proper kind of bump maps and all these sort of things, which our 3D modelers kind of know how to do, can really make something which performs well on the HoloLens and looks fantastic. And this is kind of what we call a game-ready asset.
Yeah. The next feature that we talked about and the next thing we needed to implement was the voice recognition. Like the whole application, the whole experience is predicated upon the conversation that you have with that wedge head and the way it talks back to you. So we really needed to have a voice component and a voice recognition component. Like luckily, the HoloLens comes very well equipped for this job, where it has 4 microphones built in. 2 of them are specialized on ambient noise reduction and detection, and 2 of them recording your voice. So we've had a very good experience with using the voice recognition, even in very, very loud settings like a bar or an expo. So that helped a lot. But going back to our specific application, we had 2 ways of we had 2 options of how to implement our voice recognition. The first one was using the Cortana natural language interpretations. And while that was simple to implement, it felt a bit too complex for our needs. So we landed up on a simpler solution by using the keyword recognizer that comes in as part of the whole toolkit. So what we did, we defined a bunch of keywords, and we sorted them in a kind of state machine, and we used that to drive our conversation with the wedge head, and it ended up being very simple and very effective. It also added with another implementation that we did, another trick, like the idle lines, as we call them. Like, for example, if you're in the experience and you're not interacting with the wedge head, it's going to talk to you, trying to spark a conversation. And then based on the same keywords that we had, we were able to kind of respond back as you talk back to the wedge head. So that was really really interesting.
Yeah, exactly. And using the great spatial audio capabilities of the HoloLens, the voice really was rooted in wedge head, and really helped the experience. And that helps if people don't know where he is, or kind of are looking around for him. So that was a great kind of placement aid for our users.
And last of the 4th challenge, and this is what we're going to spend our most time with, is placement. Like as Jeremy mentioned at the beginning, is like one of the biggest features that we were requested is like this application needs to be able to work in a multitude of spaces, right? Like you need to be able to run the application in a bar where there's lots of traffic, there's lots of small objects. You have to be able to place it in a skybox at a stadium, or even in a more controlled environment such as a boardroom. So this is kind of where the most of our talk is going to go, and we'll talk about how we solve this placement feature.
All right, and the challenge with this is, the spatial variation between these spaces. So what you see on my screen here are 2 representations of, kind of rooms that we were used to. So on the left-hand side is the room which, our kind of development cave, as you would. And on there you see, on the other side, you see a large conference room. And you can see that there's a lot of variation between these spaces in terms of what the HoloLens sees. So the question is, how do you make sure that you can place your holograms in a way which works for all of these different types of spaces? So the solution we came up with has kind of 4 facets, and in the background here you can see myself and our creative director kind of looking at one of the earlier revisions of Wedgehead. But it has 4 facets. The first of which is putting in a great administration mode. The second is a room scanning experience. The third is using the world anchoring capabilities of the HoloLens. And the fourth is really making sure that your room has kind of enough points to allow for great tracking. So the first mode that we introduced was the admin mode. So the administration mode is something which is hidden to the average user, but the person who's setting up the experience can enter this mode in order to place wedge head, scale wedge head to kind of an appropriate size for the space, and really understand what is in the room and if the room's been scanned kind of appropriately. So this is something which is hidden. It is triggered via a voice command, and it's kind of a best practice which we introduced for all of our kind of retail HoloLens applications.
The second pillar of this solution was the room scanning experience. So environment scanning is something that's built into the HoloLens, and it does perform this automatically out of the box. But there is a small intervention from the developer where you need to capture that information and make use of it in your application. So first of all, it's useful to see the spatial mesh. And as Jeremy introduced it, we have the admin mode where we show that mesh. And because it's an admin mode experience only, it's not customer facing, it's enough to have a low fidelity wireframe. So what you see on screen now is kind of our own version of a small modification on the out-of-the-box wireframe that comes with the HoloLens, and it's a bit more corrected and a bit more nice. But pretty much that's kind of what you'll see in the admin mode when you're scanning the room. So once we set up the mesh, we can see the mesh. We can proceed to placing or scaling the holograms within this environment, and it's kind of part of the room scanning to kind of place the objects. As more advanced features that you can introduce in this area are plane finding. It comes again with the whole toolkit, so you get the opportunity to really categorize the planes that the HoloLens is mapping into floors, ceilings, walls, in case you need to differentiate between them. Other interesting features that you can add are you can enable collisions and physics with the mesh if you need so in your application. And finally, you can guide the users to scan areas that are not explored yet.
All right, and to talk about some of the things which we want to find in these room scans, there's kind of three main areas. The first of which is holes in the mesh. So what I mean by holes in the mesh are kind of really areas which haven't been explored by the HoloLens and it doesn't know about. So in this example here, you have a credenza, and we simply haven't looked beside the credenza. It's probably dusty down there because there's also just stuff down there. But it's something we should look out for, and to make sure that it's not using that as part of the anchors I'm going to be talking about. The next of which is hallucinations. So hallucinations are really where there was something as part of the spatial mesh, but isn't there anymore. So what you're seeing here circled is where there used to be a person standing in this room. So the HoloLens has seen that the person isn't there and has reconstructed the mesh around them, but they didn't look down near their feet. So you see a little bit of that kind of remnant there. And again, this is something that when you're placing your spatial anchor, you'll want to make sure isn't part of your mesh, because if that person isn't there and the next time it scans, it won't find it, it's not a great anchor. And then the third and final thing you're looking for is bias. So what I mean by bias is where the surface mesh is out from the physical surface. And this can happen for a variety of reasons. It can happen because of a overly reflective or absorptive materials. And this really just means that it's out. So in this particular case, this is actually a dartboard on the wall, and it absorbed all the UV light. So it really came up from the wall. So again, this isn't something you'd want to use for your spatial anchor. So these are the kind of things you might want to look out for.
One of some of the best practices that we came up with for the room scanning experience were make sure that when you're scanning the room, when you're initializing the experience and scanning the room and setting the anchors, make sure the room is prepped for the occasion, right? There's no additional props in there. Whatever you need to be there is there, and make sure people are not wandering around when you're doing the scanning. And another item that it's worth mentioning is that you can also stop the scanning process once you have a good image of the room. You can stop the updates to come into your application. So the HoloLens will continue scanning, but you will stop receiving those updates, and you can be left with a clean room with nice scanning.
And this is something we used for this experience because, as you can imagine, a busy bar or a busy skybox, when you do the initial scanning, it might be an empty bar, but at the end of the night, there's tons of people milling around, and you want to make sure that those people aren't introducing kind of artifacts into your spatial mesh, which might, mess up your placement. And talk a little bit about spatial anchoring. So spatial anchoring is really how we make sure that Wedgehead maintains its place within this environment. So all we have to do is simply establish a spatial anchor at where we want to place them. So what this does within the HoloLens, and this is actually an operating system level construct, is it actually creates a special coordinate system for this anchor to fix its real world position. So what's great about this is it automatically adjusts this anchor as it scans the room with more detail. So what you can do is look at a table, place the hologram on that table, and as you scan the room around, it might get more information about the size of that table, the placement of that table within the room, but because you've established that special coordinate system for the placement, the hologram will remain fixed to that surface as long as it can recognize the points you used for that spatial anchor. So this is really an incredible concept and allows your holograms to not kind of drift as the HoloLens establishes more about the room. And what's even better is that this is actually incredibly easy within Unity. So within the Holo Toolkit, there's a World Anchor class, and this really enables you to easily place your World Anchor. All you have to do is attach this script to your game object, and it goes. It allows you to persist these anchors, so if you want to save it into the HoloLens and retrieve it the next time you launch your application, you can do so. It allows you to serialize these spatial anchors, so you can send them to another HoloLens to allow for a shared experience. And it also gives you a lot of great tracking events as to when these anchors are lost or regained. With that point, you really should consider when you're using spatial anchors how you deal with the loss of tracking within your application. So there's kind of two general options. The first of which is to simply hide the hologram. So this makes sense if the object, the hologram, only makes sense when paired with the physical object. The second option which you can do, which is kind of similar to the HoloLens shell, is to at that point body lock or make your hologram a tag along. And that's actually what we did for our experience because it never really made sense for Wedgehead to disappear from our experience. So that's something when you use spatial anchors, you should at least consider what your strategy is going to be.
And finally, the last step of the placement strategy that we have is like room tailoring. Like ensure that the room you're delivering your experience in is at least, the very least, good for the HoloLens scanning experience to perform properly. So you would want a room with not very many reflective surfaces on them. So if you have a mirror or you have like very, very shiny objects, they won't really be scanned properly, so you'll end up with holes. If you have absorptive materials that will not scan as well and will create biases in your scanning environment, very flat surfaces that don't have any contrast on them will not scan very well. So ensure that you have like some differentiators, some props. Maybe you can use a poster here and there. So really try and make the room as good as possible for the room scanning experience to work as good as it can.
So the Shocktop and Wedgehead was really the first step in Anheuser-Busch's look about how to use holograms and mixed reality as part of their kind of marketing campaigns. So we've had a lot of talks about what's next. What is the next step in terms of this? And we're talking with a lot of their brands and how we bring HoloLens and mixed reality to Michelob Ultra and PGA events, how we bring it to any number of sporting events, and this is what we're looking for our next endeavor in this field. And we're working with their Beer Garage brand in order to identify the next opportunity. So to give you a few tips that we've learned from our first holographic experience, first of which is really to make sure that when we're doing these end consumer demonstrations, make sure you use kiosk mode. It can avoid a lot of the headache you can have managing this experience. If you are going to use your application in a variety of different spaces, make sure you at least consider having some sort of scanning mode, even if it's very rudimentary and just shows the default mesh. It really allows the administrator to identify what's in the room, if there's any bias, is there any kind of holes, and then you should also make sure to use spatial anchoring for any objects which require world locking. So anything which should remain fixed in place, use these spatial anchors. And then finally, make sure that your space is good enough for tracking, has enough contrast, and isn't kind of a blank white wall or something like that. So anyways, I'm Jeremy.
And I'm Alex.
And thank you for your time.